In today's lesson, we're going to be looking at adding and subtracting rational expressions. This will look pretty similar at first glance to what we were doing in our last lesson with multiplying and dividing rational expressions. And in the same way, there's really not that much that I'll have to teach today. It's mostly just going over some examples, and then most of what you'll be doing is practicing with this. The difference that we'll see between these is the fundamental difference between adding and subtracting fractions compared to multiplying and dividing them. When we multiplied and divided, our process was pretty much just factor things out and cancel what we can cancel, right? But when we are adding or subtracting fractions, we know that in this case, we have to get a common denominator in order to be able to combine them into one fraction. So the main thing that we're going to be looking for to start with is to identify the least common denominator in an expression. Okay. And if you take a look at the examples that we have here below, it starts off very simple, right? It starts off with no variables, just adding basic fractions, and then we'll build up and see how these things change, okay? So as a refresher on your middle school process for adding and subtracting fractions, we need to figure out what is the smallest multiple that both 6 and 8 can go into. And in this case, that is going to be 24. So our least common denominator in this case is 24. Then from there, I just need to think, what does each fraction need that it's currently missing? So if I need to get my first one to have a denominator of 24, I know I need to multiply that by 4, okay? But I have to be careful that I'm multiplying it by 4 over 4, because remember, it's an expression, and we can only multiply expressions by 1. So it needs to have 4 over 4. And our second fraction has 8. It needs to get to 24, so we're going to multiply it by 3 over 3 in this case. Okay, we work those out. That's going to be 20 over 24 plus 21 over 24. And then when we add these, remember how this works with fractions is we're going to add the numerators. So that's going to give us 41. But once we get that common denominator, the denominator stays the same. So 41 over 24. Okay? And so there's our process. You'll notice that the instructions for this part are just asking us to find the LCD. I'll work them out fully on these first couple just to kind of give us a refresher on how that works. But then after that, we'll just practice identifying what that least common denominator is. Okay? If I look at this second one, okay, I've got a denominator of y squared and a denominator of xy. Okay, so what's the minimum that we can get that contains all of this? In this case, well, we know that we're going to need one x because that's in this. So it's going to be an x. And then this has two y's. This has one y. We need to fill all of those up. So we need two y's out of that. So we're going to have the x, y squared as our LCD. On this one, again, I'm thinking, all right, I look at my first fraction. What is that missing that it needs? This one's missing an x value, right? So I'll multiply it by x over x. And what's the second one missing that it needs? It needs one more y. Okay, so I'll multiply by y over y. And then let's just work that out. So that's going to be 2x squared plus 3y over xy squared. And there we go. That is our simplified expression. Okay? If this is clicking for you, then you're going to feel great moving through these, and you'll be able to go through them pretty quickly. Okay? So if you feel good skipping ahead and checking on my work after, feel free to do so. I don't want to hold you up if you feel like you've got the idea down. These next few, I'm just going to look for what our least common denominator is, okay? Looking at this third problem, x plus 2 and x minus 5, despite both having x, actually are totally separate in terms of factors. So our LCD in this case is going to be that full thing. It's going to be x plus 2 times x minus 5, right? So in order to change that first one, I would need to multiply it by x minus 5 over x minus 5, and this second one, x plus 2 over x plus 2. Okay. Next, looking at x and x plus 3 as our denominators. Again, notice that this x is different than that x plus 3, right? Imagine if that x value was 5, and this one was then 5 plus 3. Well, 5 and 8 as denominators are totally different, right? So in that same way, x and x plus 3 are going to be totally different. So then our LCD is just going to be each of those multiplied together, x times x plus 3. Now when we go to the next line of problems, on these we see things that are more complicated. And just like in our last lesson, a lot of what we're going to be doing here today is factoring to help ourselves out, okay? So I could say that I have a common denominator here of these two things multiplied together, right? But if I factor it out, sometimes I'll be able to see a way I can decrease that amount, right? Those could be a common denominator, but not necessarily my least common denominator. So let's factor this. That first one's going to come out as what? X minus 8 times x minus 3. And the second one, what? This will be, we've got a perfect square trinomial here, right? So x minus 3 squared. All right, this has two x minus 3's that we have to account for. This has one of them, so we'll have to give it one more, and then that x minus 8. So our least common denominator in this case is going to be x minus 8 times x minus 3 squared, because this one contains two of those, so we need both of those to show up, okay? So if I'm trying to fix this into getting that common denominator, I'm going to have to multiply this by x minus 3 and this one by x minus 8. Okay, let's keep going. Here again, let's factor. I can take out an 8, x minus 3, and a 10 times x minus 3. So they both share that x minus 3, so I know that's going to be a part of our LCD. Then I'm just going to look at my 8 and 10. What's my least common multiple between those two? In this case, that would be 40. So our LCD for this problem is going to be 40 times x minus 3. Last one in this section, again, just more factoring. 15 times x plus 4 and x plus 5 times x plus 4. What's our LCD going to be from this? Well, we're going to need that 15 in there. Each of these have an x plus 4, so we just need one of those in, and then we're going to have to include the x plus 5, okay? So that's our full least common denominator. We would need to multiply this fraction by the x plus 5 and this fraction by 15 over 15, okay? So there's that first section, just identifying those least common denominators. That's what your first step or first goal in all of these problems is. You'll start by factoring when you need to, and then figure out what that least common denominator is, okay? Let's go down below and we'll actually fully work out one of these that's a little bit more complex. Just like in our last lesson, with multiplying and dividing rational expressions, we will still have to deal with excluded values in this one, okay? When working with rational expressions, you must identify any excluded values, okay? And think back to what we've done with functions. An excluded value is basically going to be the equivalent of a vertical asymptote or a whole, right? These occur when the denominator is equal to 0. Okay, So let's take this example, we'll work through it, and we'll find any excluded values that we have. First thing that I want to do when I approach this is factor. All right, so let's factor what we can. So I'm going to have -3, and we've got a difference of squares in that denominator. So that's going to be 3x plus 2 times 3x minus 2. And then our second fraction, we've got 1 over, looks like we can just factor out an x from that. So x times 3x plus 2. All right, let's figure out our LCD. All right, they each share that 3x plus 2 in common. So I'm going to need one of those. We're going to need a 3x minus 2, and we're going to need an x. Okay, so LCD I'll write as x times 3x plus 2 times 3x minus 2. Now let's change our fractions to get them into that same form. So what does our first one need that it's missing? An x value. So I'm going to take that 3x, I'm going to multiply by x, and then in our denominator, we'll multiply by x as well. And that's the only thing that needs to be added to this one. And in our second fraction, what are we missing? We're missing a 3x minus 2. So that's what we'll have to multiply into this one. So I'll say 1 times 3x minus 2 over x times 3x plus 2 times 3x minus 2. All right. Now from here, we can just go ahead and combine these together into one fraction. So that -3x, and then I'm going to have plus 3x minus 2. Notice, one thing that's important to notice is whatever this sign is needs to distribute to that whole following numerator. When you're adding, that means you don't have to do anything. But when you're subtracting, you'll need to make sure that you distribute that negative through that whole numerator. So just be careful with that. I might just show this by throwing it in parentheses here, that I'm going to be adding 3x minus 2 over our denominator. Okay, and then from here we just want to simplify. Okay, -3x plus 3x is actually going to cancel out. And so in our numerator, we're just left with -2. And that's going to be over 3x plus 2, 3x minus 2. Okay. When we're dealing with these, it doesn't really apply to this problem, but in other ones it will. It's going to be fine to leave our denominator in its factored form, but our numerator will always want to fully multiply out and get it into fully simplified form. So just be careful with that when it comes up. We'll see other examples with it. Okay. And then we also have to think about our excluded values. So what can x not equal in this case? Well, x cannot equal 0. X cannot equal -2/3 or +2/3. So we need to write out those 3 excluded values. Let's go to the next page and we'll work through another example with this one. And in this case, we've got 3 fractions to deal with. That doesn't automatically make it more complicated, but there's a little bit more that we'll want to think about in this case. When I first look at this, if I'm thinking about my LCD, looking at those 3 denominators, those all look distinct and different to me. So my first thought for this least common denominator would be x plus 3 times x minus 3 times 3 minus x, which works as a common denominator, but if we pay attention carefully here, we can actually get a smaller least common denominator in this case. And if I can make it smaller, if I can make it less to deal with, then that's always going to be better in these problems. And what we're able to do in this case is actually notice that that the denominator in this fraction is just multiplied by -1 from the denominator in this fraction. So what I could do to make those two into the same thing is I can think of it two ways. I can think of factoring out a -1 from this, or I can think of it as, I could say I can multiply it by -1 over -1 just to this fraction. Either one of those are fine. Let's say I'll just multiply it by -1 over -1 in this case. Right? What is that going to do? Well, for this, that's going to give us then I'll just say -x plus 2. I won't distribute it. And then -3 minus x. Well, if we look at what happens to that, if I distribute that, that becomes -3 plus x, or x minus 3. And now these two have that same denominator, so it's just less for us to deal with as we go through the process. It's going to save us a lot of work that we would otherwise have to do. So I'm going to rewrite what we have in this case then. And so I'm going to say it's x minus 3 over x plus 3 minus 1 over x minus 3. And then I'm going to take this and write that as our new thing. So I'm going to say plus, I'll distribute this negative now. So I'm going to say plus -x minus 2 over x minus 3. And looking at this, well, I notice that we can now just go ahead and combine these two fractions together because they now have that same denominator, okay? So let's go ahead and do that. But another thing I want to point out, again, we always have to be careful anytime we have a negative, and we've got subtraction in this case. So what I want to do with this is I can take this subtraction and basically just apply it into the fraction and make that a -1 and then say that's plus, okay? And if I do that, now I don't have to worry about my order of operations because everything is now being added in this case, and I could just take these two fractions together and combine those. So let's do that on its own. So plus, all right, we've got -1 plus -x minus 2 over x minus 3. Okay, what does that give us then? Let's call that -x minus 3 over x minus 3. Okay. If you're wondering if you can cancel out top to bottom in this case, you can't because basically because the signs are not going to match up properly from top to bottom with that -x there. But we'll take that as it is, and then let's bring down that first fraction. So let's do x minus 3 over x plus 3. Now combined with this one that we've simplified. Okay, so we did a lot of work to lead up to this part. Now we're going to kind of pick up with what we've done more normally, which is let's find our LCD at this point. And then multiply through to make this work. Let's see, I'm going to shrink this down, get a little bit more space. All right, what is our first one? Need that it's missing is going to be an x minus 3 in that numerator, or sorry, in the denominator. Okay, what is the second one? Need that it's missing. It's going to need an x plus 3 in both. All right, we've done that. Now let's start simplifying. All right, as I said earlier, we always need to multiply out the numerator. Denominator is fine to stay in factored form, but numerator is going to need to be fully simplified. So I'm going to FOIL this. Okay, that's going to be x squared minus 6x plus 9, and then plus this, which is going to be negative x squared minus 3x, so minus 6x minus 9. And then over, again, I'll just leave it in that factored form. This last step, simplify what we can. We're going to see here, look, that x squared and negative x squared will cancel. That 9 and negative 9 will cancel. So we're actually just going to have then negative 6x minus 6x, so negative 12x over that denominator. There's our simplified form. And then don't forget about your excluded values. What can x not equal? In this case, x cannot equal 3 or negative 3. That's one of the more complex problems that we'll deal with, particularly just because the denominators up here are annoying to start with. But it's good to see how that works, and it's important to just look out for any times where we can simplify what our LCD would look like when we can. Okay, I'm just going to do one more problem with us in this, and then you'll have the chance to work and practice on your own. Let's take a look at one word problem here. So I'll do this first one in this case. So we've got a train that goes 30 miles an hour to its destination when it is fully loaded, and it goes faster on the way back. With empty cars, it goes at 40 miles per hour. In terms of D, find the total time that it takes in this case. Well, we're going to work on a distance rate time problem here, right? So with that being our general formula, let's think about how we can apply it into this situation. So if time is equal to the distance over the rate, in this case, I'm going to think of our distance over rate. Basically, we've got two different parts of the trip. So the first part of the trip is going to be the distance, let's say the distance there over the rate there. Let's call it 1 and 2. Might make more sense. So distance 1 over rate 1. And then that's going to give us the time to get to the destination plus the time to get back from the destination. So distance 2 over rate 2. And that would give us then our total time. If we can think that through, then we just need to know what to plug in. Okay? Well, in this case, the distance is the same there and back, right? So I'm just going to use D for both the numerator and the denominator. Or not for both fractions, I mean. The rate going there is 30 miles per hour, and the rate going back is 40 miles per hour. There's our expression, okay? From here, let's just simplify. What's our least common denominator between 30 and 40? Is 120, okay? So let's take that first one and multiply it by 4 over 4. So we're going to have, let's see, 4D over 120. And let's take that second one, multiply that by 3 over 3, 3D over 120. We now have a common denominator. Let's just add these. So our total time in terms of D would be 7D over 120. And there we go. Okay. If you try that next word problem below, you're going to see that it's basically the same idea as this one. So if you want more practice with this idea, just try that next one and see if you can work that out. And then what I want you to do from here, spend some time practicing on these problems on the next 2 pages, and you're going to get more practice with that in your homework. Okay?